This episode of Fluid Power Forum is sponsored by IFP Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFP spans the 13 central states from Minnesota to Texas. For more information, visit ifpusa.com. Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Langro, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, please follow us on Twitter. You can find us there at the NFPA. And make sure to share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. That is one of the ways that we source topics for our show. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You can find us on Apple Podcasts, we're on Spotify, we're on a lot of the other podcatching services. Wherever you find us, subscribe and then give us a quick rating. Those ratings really do help more and more of our friends in the industry learn about the show and join in on these important conversations. On today's show, we have a special presentation. Fluid Power Forum recently hosted an education program at PACK EXPO, the large trade show for the processing and packaging industry. Our event there focused on advanced pneumatic solutions for packaging machines. Now, we know that pneumatics is a reliable and cost-effective technology for many of the core actuated functions on those machines, but it's becoming even more indispensable through its integration with smart sensors, with network connectivity, and now pneumatics is providing even more capabilities, from reduced energy consumption to preventative and predictive maintenance. So we had three great presenters from three pneumatic companies at our event. Each one showcased the latest technologies that their companies are bringing and how they're providing these benefits to packaging and other industrial machine manufacturers. One of those presenters was Frank Langro, the Director of Product Market Management for Pneumatic Actuation at Festo. And what follows is a recording of the presentation he gave at our PACK EXPO session. If you want to follow along with Frank's slides, we've put a link into the show notes. One link will allow you to download those slides as a PDF. Another will allow you to download and watch a video that we've created where we've done our best to sync up Frank's recording with those slides. Either one's a good resource for you, but I'm sure you'll find value in just listening to the recording itself. Frank's presentation was titled Smart Pneumatics for Packaging Equipment.
Thanks, everybody, for taking the time this afternoon away from the show to learn about smart pneumatics and what's going on. And so I'd like to get started here and just talk about what exactly are smart pneumatics. So here I show a cylinder, a filter regulator, and a valve. I mean, with the cylinder, basically the rod will extend and retract whenever it receives an air signal from the valve, right? And the filter regulator, it regulates a pressure based on whatever manual input somebody gives it. And the valve will turn on and off and shift direction, again, based on whatever input is received. So really, they're acted upon. They're not exactly smart. They're not adding any intelligence to the system. They get told what to do, and they do it. They don't talk back, basically. They do what they're told to do. Now, what if you added a cylinder switch, for instance, to the cylinder? Perhaps a cylinder switch that also gives you a value, indication of position, not just that the rod is extended or retracted, but an actual analog value. That's one thing you can do. Or if you had a device that would regulate pressure and flow in your air prep and also record the machine profile, the pressure profile of the machine, how it works, as it's operating and cylinders are shifting, and you get a fingerprint essentially of that machine. Or if you had a valve that can be reconfigured based on software to act as a different type of valve or to do functions like flow control or pressure control based on some software commands. So this starts to enter the realm of smart pneumatics, what I would consider smart pneumatics. So what are the challenges that OEMs and packaging OEMs are faced with? I think as you go through the show this week, you see flexibility is something, fast changeover, because they're running multiple products in different sizes, so they need to be able to change over quickly. Reduce downtime, another big topic, right? Also monitoring. I've seen this too, where the health of the machine is something that people are more and more concerned with. Efficiencies, reducing waste, both in energy consumption as well as in materials. I think that's one of the things when you see these green initiatives and a lot of the machine builders are really trying to cut down on the materials used in terms of packaging and so on because of initiatives from their customers. I just want to step back and look at basically the evolution of production. Typically you had machines, manual machines like a manual lathe here. Uh, it manually operated. Then you went into dedicated machines where you had machines that would produce the same part in high volume over and over. And then you started to get into flexible manufacturing, and most machines today have some flexibility in there that you can run different sizes or so on. And then you get into modular and reconfigurable machines where maybe depending on the features that a customer wants on a machine, they may add on something, maybe a wrapper or uh, some other function that would extend the machine and just beyond just packing and wrapping and palletizing. And so you get into this modular reconfigurable type machine, and that goes more and more towards the flexibility aspect. Just a quick snapshot of all these different, same product, right? It's Coca-Cola, same exact product in each of those cans, but or bottles. But you can see the variety of different shapes. And then when you throw the holiday season in, right, you start to get different packaging as well. And so that goes into that flexibility that the machine builders are looking to implement for their end users. I just want to show this slide from Gartner because I think it really is a nice overview of the type of analysis that goes on, the amount of human input that then has to happen till you get ultimately to a decision and then the action. And so a lot of it was a basic business intelligence, right? You had data and you have what it would call descriptive. It basically tells you what happened. Something happened and you want to be able to identify what it was, what occurred. And then with this type of data, you start to enter the realm of diagnostic data, like why did it happen? And you can see as you get more and more information and more data, the human input starts to be decreased. When you get into advanced analytics, everybody's starting to look towards predictive analytics. What will happen if I recognize something on the machine? Can it tell me what's going to happen next week? And then, ultimately, I think where everybody is striving to get to is prescriptive analytics. And basically, just like a prescription medicine, it's preventive, right? You do something so that something doesn't occur. So prescriptive analytics would be, what should I do in advance so that I don't have an unplanned failure, or um, I don't produce defective parts, or I optimize the material usage in the machine. So that's ultimately the end game that everybody is striving towards with advanced analytics and so on. So I just want to keep that in mind and put it out there, because I think this was a really nice example of the different types of analytics that are out there and currently used on varying levels. So coming back to my simple cylinder, I mean, for many years, people have used cylinder switches, and basically this tells you when the piston is at one position or the other position at the end of stroke. What you see now also is that you may get position transmitters. And for example, Festo offers position transmitters that have different degrees of ranges. As you move towards the end of stroke, you get into giving analog values. And it could range anywhere from 10 millimeters to 50 millimeters, depending on the position transmitter, as well as the length of the cylinder and the stroke of the cylinder. And one of the things that this would be very useful for is maybe if you wanted more detailed information, if you're checking a part and you're using the cylinder to check the thickness of maybe a material, a packaging material, or a film or something like that, you can now see if it's within spec, if it's out of spec, and avoid using it. So I'm thinking in terms of packaging material, maybe you don't want to go above a certain thickness because it's not needed. And here, perhaps with a analog position transmitter, you could start to get information like this. Now we've also released a new cylinder switch, and while it's typical, it goes back to sensing the end position of the piston. The interesting thing about this switch is that it is a self-teach switch. So typically with cylinder switches, you have to be fairly precise, put them in place. With this new cylinder switch, you really just have to put it roughly in the area, and it will teach itself. So normally, you would need power, you need visibility to recognize the LEDs, and also often these are run without loads running through the machine, so you still get piston seal compression and things like this, which will actually move the position of the piston slightly. And sometimes these are in hard to reach locations, so it can be challenging and time consuming, especially a machine with a lot of switches, a lot of cylinders. So what this switch does is that it has a range of sensing. And so really all you need to do is roughly mount the switch in here. And once the cylinder runs 4 times and runs through the switching zone, it actually teaches itself it actually teaches itself uh, the correct um, the correct position, and offers a signal as the piston reaches the signaling range. So here you do have some intelligence as the product is teaching itself. Before I mentioned about air prep, and if we were measuring flow and pressure regulation, doing pressure regulation. Now imagine if you had a device where you're measuring flow and you could see this profile during normal production. And now you recognize when there's no production going on, you can now react and put this into a standby mode. So now you cut off the air to the machine. Typically, I mean, machines leak, and sometimes they leak overnight, and there's air, and it's drawing demand on compressors. And so with something like this, you could prevent that. What this also does is it's getting data that you can that you can supply to data controllers and cloud storage for further analytics and applications. A closer look shows, and these things are configurable by the user, how long you want to wait to recognize a downtime, um, what pressure you want to go to standby, whether you want to drop it all the way down, or maybe you want to keep some pressure in the machine because of some function or some preset condition to do a startup. It'll also detect if the machine starts leaking. It can also go into standby pressure mode where it allows the pressure to build back up if it gets too low. So these are things that clearly it's not just a pressure regulator that's manually adjusted. There is intelligence as the device is acting and reacting based on the environment and some of the settings that you give it. I mentioned the valve before, and I just want to describe, because I always like this visual of a smartphone and a smart valve. So everybody's phone now, it's more than a phone, right? You can send emails and text messages. You can have music and other media on it. You can play games, take pictures. It all depends on what software, what apps are loaded on the phone, and you can then create, use it for these different functions. With Festo's motion terminal, the VTEM, the valve itself is configurable based on software apps. So instead of having to have a separate valve for a 5-3 valve or a 3-2 valve, or add in a physical pressure regulator, um, or a proportional valve, you can actually do it via the software with the same set of hardware. And so that's pretty interesting because the hardware then becomes reconfigurable. And if you start to think about things like spare parts or, um, just the complexity of the system or even security, because now you're controlling things via the software. So you really do prevent some manual tampering and things like that. It really does open up a new world of machine building. So we know the basics of a directional control valve. I'll just explain how this works a little bit. You have a spool design and you have control surfaces. Typically, in this case, there's 4 control surfaces, and it's physically linked together. You can see that the link here, it's a mechanical spool. Its geometry is based on the control surfaces and the valve body. And you have the air passing through depending on what position the spool is. And if you go into different valve functions, it requires a different geometry of spool. So there's physically different hardware that's required. What the motion terminal does is it uses 4 diaphragm poppet valves inside of a single valve housing, and each of these is controlled by 2 piezo electric pilot valves, proportional valves. So now you get the proportional action in here. And by putting them in this bridge circuit and connecting them to outlet ports 2 and 4, you can create really just a number of different functions. There is a pressure sensor at each outlet port integrated inside the valve. So it's all self-contained within the valve like this. And that brings the closed loop feedback during the algorithms of the valve. And just in case you're not familiar, piezoelectric, this is a ceramic. It's actually an old technology, and it's an old phenomena that if you put a high voltage on this, it would deflect. And so there's actually a number of different types of piezo um, valves that can be made. We use the bender, where it basically deflects up or deflects down and opens an orifice, creating more flow and less flow. Sometimes you can use a stack where you stack them on top of each other and they expand and contract. Um, different styles, but that's what gives us the flexibility to control these pilot valves, to create the output on these poppets, which give us the functions of our software apps.
This is Eric Langro cutting into our recorded presentation for just a moment to tell you about IFPE, the International Fluid Power Exposition. IFPE is the place where you'll learn everything you need to help your company stay at the forefront of the megatrends affecting your business and industry. From sensor technology and data analytics to robotics and automation, you will see the latest innovations in fluid power that will help your machines and applications achieve your technology, performance, and business goals. Only at IFPE can you have those in-depth technical conversations with other engineers and other executives to help you spark new ideas, or talk with suppliers about your specific challenges and the solutions that they offer, or find new suppliers and new ways of doing things, or attend innovative education classes and sessions covering the latest fluid power topics and industry trends, including some college courses providing professional development hours. No other trade show brings together as many sectors of the fluid power, power transmission, and motion control industries together in one place. And this event happens only once every 3 years, in conjunction with ConExpo ConAg, the largest international gathering place for the construction industries. The next IFPE show will be held March 14 through 18, 2023 in Las Vegas, Nevada. To learn more and to reserve your place, visit ifpe.com.
I just want to show you, thinking about now, here you have a valve manifold up here in the upper right, and we're running some end of arm tooling and we have vacuum generators. And so to do that, normally you would have two valves where you're turning the vacuum on and off. And that all works well and good. But now if you wanted to change that tool and put a gripper, there you would need a 4-2 valve so that you could exhaust, so you could extend and retract, right? Basically. And you can do that with the same exact hardware that you had before. You didn't have to change out the valve pack or have additional valves. So it really is pretty, like I say, it opens up the world for machine designers to really reinvent how they do certain things. Another example is end position stopping. What this animation shows, without bumpers, here you see the unit slamming into the end position and you see the water vibrate, right? So in order to eliminate that and reduce the impact energy, you put shock absorbers in, and now it cushions this. Now, shock absorbers, sometimes they could be challenging because you have to size them properly. If you underutilize a shock, it tends to fail. You have to worry about leakage of hydraulic fluids as well. So here with the motion terminal with a analog position sensor, you can change the motion on this and put a soft motion basically. So as the piston goes towards the end position, you can start to balance it on the other side by restricting the air on the exhaust side. So with that precise control of the valves, you can create what's called a soft stop motion, eliminating shocks. Like I say, actually reducing one item, a mechanical item that could pose some problems or introduce irregularities into the machine. Another application is proportional pressure control. Here, you'd have individual proportional pressure regulators, but by using a motion terminal, you can do that with your valve. And I think, this is a common application in terms of web tensioning or any type of film or element. And we see that a lot in packaging equipment, flow wrappers, labeling equipment. This is something also that I liked quite a bit is timed motion because it really highlights some points. So you can set the times so that they're synchronized. It could be different strokes, like you see in here, that these cylinders are different sizes, different strokes, but we're timing it to the same. Here we change the sequencing, and maybe that's necessary on a machine. But the thing that here's again where I get into smart pneumatics is the output here, or what we're trying to do is move in a certain time frame. And what will happen is that the valve will compensate based on pressure fluctuations in the system. And so it is self-learning in a way, in that it's going to correct itself to switch in that specific time frame so that the cylinder is extending and retracting as defined. So again, there is some intelligence now that moves into the world of pneumatics. It's not just a simple bang bang um, valve switching anymore. So I wanted to just show a couple of applications as well. Um, Pressure and flow by far are the main applications that we with the motion terminal, particularly in packaging. It's also easy to change the parameters and very flexible to set up for running multiple products. And I mentioned earlier the safety aspect, really security, not that it's machine safety, but more security regarding there's no manual adjustments on the machine. And so things are protected from tampering. When there's a button, a knob, somebody wants to twist it, turn it, see what happens. Something's not working. They start adjusting things. It kind of keeps that aspect locked out and prevented from happening. So here's a animation of a very typical type machine using vacuum, and you're picking up product of certain size and placing it in the box. Now there's going to be another product, different size. You need more vacuum force because it's a higher load. You also have to change the stroke of this cylinder because it's moving up over the lip of the box. It's also not extending the same way as the other one. So this is, running different product, and having that flexibility. And if you think about variety packs and holiday packs and all sorts of things that are constantly going on and demanded by customers, um, this is really a seamless changeover. And here's a real life application that shows essentially the same thing. Different size cups, different stroke. So different positioning of the cylinder. Um, and proportional pressure control with the vacuum because of different loads on here. So I think if you walk around the show, you probably see things requiring this type of control. There's another, again, the flexible. We have a customer, Advanced Manufacturing Technology. They're actually at PACK EXPO this year. They're at booth S3076. But they manufacture these conveyor lines, and they're holding bottles and running them through. And what they use this motion terminal for is to do the quick changeover so that there's different bottleneck sizes. Maybe the bottles also have also different capacity and loads, so they need to be held with different forces. And this allows them to do that stuff very quickly. The cylinders here are controlled by the valve pack, and moving these guides basically to change neck rails that hold the bottle. So while there's a number of different apps that can be applied, I mean, most common are pressure, motion, and flow control, and you can combine them all together. And so, I'd say, am I allowed to use the term smart pneumatics now? And I think so. And coming back to this slide, I wanted to come back to this point that I introduced earlier, because here we're getting into some of this predictive with the E to M air prep model, where we're predicting what's going to happen based on the machine profile. And this is really a lot where Festo is right now, is on the predictive side. We haven't really gone the next step too deeply, but we have a lot on diagnostic, descriptive, and really now moving into the predictive side. And I think you could see, though, with the issues of having qualified machine techs, a workforce that can utilize, shortages of workers, more automation coming into play, being able to reduce the human input into these aspects is really going to be a factor more and more in the future. And so companies will be challenged to bring solutions, innovative solutions that can push the envelope into ultimately getting to prescriptive type analytics. I think Bradley spoke a little bit about the digital factory, and this is the key, and we talk about smart pneumatics. Obviously, there's electrics in here too, but connectivity, that's what's needed from these devices, is that you need a way to connect and get data. Because once you have access to data, there's a bunch of different platforms, um, be it OPC UA, Factory Talk, clouds, and so on, that the data can be analyzed. You start to get into smart operation, and again, you move up the chain. Ultimately, you get the data acquisition, you process the data. Maybe you go from an edge device into an IoT device, ultimately getting into the artificial intelligence where the machine starts learning and tuning itself. And we saw a little bit of that, like on the motion terminal, where it knows what the parameter, and knows the cycle time that you wanted to make with the cylinder. So it adjusts its algorithm internally to compensate for variances in the machine pressure, for instance. And this is a whole ecosystem of different devices. And like I was saying earlier, you just have to get the connectivity to bring this up a level and ultimately decide how far you go, whether you go just into a PLC, whether you start to go into an IoT gateway, whether you start going into cloud and other things. But the data is there. IO-Link was a big step, with simple things like sensors and so on. But the data, it's becoming an expectation, is what I would say, is that more and more it's an expectation that you can get some data out of these type of devices, because the customer may want to use it at some point in their analytics. So Festo also has a new product called Festo AX, and it is basically an industrial intelligence. Um, and what we look at is things like energy monitoring, leakage detection, which will lead to compressor optimization. We look to get the data and provide it to other parties, if they're using a third party type device. We also have a maintenance package, which can signal and prompt somebody on different incidents and logs and so on. Uh, looking to get into the predictive maintenance as well, anomaly detection for failure prediction. We see some early adapters, primarily automotive, but food and packaging and electronics industry. And at our booth at the show this year, we're at N6213. We have our digital factory demo. It's a rather simple gantry system. And these are examples of a dashboard that can be generated. Typically, we'll look at health of the machine, but really what it brings transparency, and the data can be used any way. Typically, you're going to see less waste, more availability. Part of the less waste is the rejection cost and unplanned downtime. These are rough numbers, obviously, depending on what you choose to monitor, what process is critical. These numbers can vary, of course. But I'd like to just recap the improvements that we see with smart operation. Immediate repair, recognizing failures quickly, and pointing them out so that you can go fix them immediately, not have to hunt and shoot. Recognizing deviations in the operation before they become a problem. Again, this goes into knowing your machine and how it operates and what the critical processes that you're doing are. But once you start to develop that fingerprint of the machine, it starts to become clear when you start to get failures. You start understanding what are the precursors to that failure occurring. The data collection, big key here. Also, smart operation, the flexibility of machines. I think that's a clear demand. When we talk about quick changeovers, we see product life cycles are shorter, so we really can't afford to use dedicated machines and dedicated production lines like years ago. I mean, ultimately, there was a phrase I always heard with like Industry 4.0 or smart manufacturing, is that you want to use high volume manufacturing techniques, high volume production techniques for a lot size of one. That's the thing. You want to use automated equipment, but be able to do this in a cost-effective way on small lot sizes. And that's where increasing flexibility, changeover, this all comes into play. And then energy, reducing cost, green initiatives, reducing waste, recognizing air usage, recognizing material usage, cutting down on that. These are all important things. And I know many companies have some sort of green initiatives, whether it be, specific to cutting air or more general on carbon, footprint. And carbon footprint can be reduced in a number of ways that impact production.
And that is going to wrap things up for this episode of Fluid Power Forum. My thanks to Frank Langro, who spoke at our sponsored education program at PACK EXPO, and whose presentation has been the recorded feature of this episode. If you'd like to connect with Frank, learn more about Festo's Smart Pneumatic Solutions, you can connect with him via email, and we've put a link to Frank's email address in the show notes for this episode. Remember, if you like our podcast, please follow us on Twitter. We're there at the NFPA. And make sure to keep sharing those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. We truly want to hear from you on the kind of topics you would like to hear us address on the show. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, reminding you to join us next time in the forum.